Our experiment had to do with the stirring speed and the rate at which different salts dissolved.
Our objective was to test the theory that stirring speed affects dissolving speed. The faster a substance is stirred, the faster it will dissolve. The slower it is stirred, the longer dissolving will take.
We tested 3 different salts in 200 milliliters of water, all at 3 different speeds of stirring.
We expected the salts to dissolve slower at slow stirring speeds and faster at faster stirring speeds.
We used 1 teaspoon of rock salt, 1 teaspoon of kosher salt, 1 teaspoon of table salt, 1 metal plate, a stir bar, 200 milliliters of water in a beaker, and a tank.
We tested table salt first by putting the beaker onto a metal plate with a magnetic stir bar inside. We filled it with 200 milliliters of water and turned on the stirring at speed 9. We then poured the salt and timed how long it took to dissolve. We then repeated this at speed 6 and 3.
We then repeated that with the kosher salt and the rock salt.
We found that at slower speeds, the salts often stuck to the bottom of the beaker and took a long time to dissolve than at faster speeds, where the salt didn't stick to the bottom and was dissolved faster.
As the table of data shows, salts dissolve slower when stirring at slow speeds. When stirred faster, they dissolve faster. Also, we found that larger salts dissolve slower than smaller salts.
As you can see, as stirring speed increases, the time it takes to dissolve salts decreases. When stirring speed decreases, the time it takes to dissolve the salts increases.
We could conclude that it takes longer for solids to dissolve at slower stirring speeds. As speeds increase, the time it takes to dissolve solids will decrease.